Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. Today's problem is on finding the k closest points to origin. Let's jump into the problem statement, understand it and start solving. So last time we have solved the 0, 1 matrix. We'll mark it checked. You can find it in the list. Let's start with k closest points to origin. Okay. Yes, I have created this video earlier, but again it was not recorded properly, so I'm doing it again. We'll understand this example. Given an array of points where points I equals xi yi represent a point on the xy plane and an integer k, return the k closest points to the origin. The distance between 2 points on the xy plane is the Euclidean distance x1. So we have the formula x1 minus x2 whole square plus y1 minus y2 whole square and then root of it. You may return the answer in any order. The answer is guaranteed to be unique except for the order that it is in. Okay. So we are given an array, okay, points that contains a list of points, that is x1 y1 coordinates on the xy plane, and we have to return k total elements, k total points that are closest to 0. So for example, points 1 3 exist here, and minus 2 2 minus 2 2 exists here, and k is equal to 1. So we have to return one closest point. How will we find the distance? So if you remember the Pythagoras theorem, you can use that. It will be square root of this side, which is 3 square, plus this side 1 square. So root of 3 square plus 1 square would be root of 9 plus 1, root of 10. So we have the distance between 1 and 3 and the origin is square root of 10. Similarly, distance between minus 2 2 and origin would be root of 2 square plus 2 square. So root of 4 plus 4, 8. So square root of 8. So we can see square root of 8. Now square root of 8 is smaller than square root of 10. So minus 2 2 is the answer, because k was equal to 1. If k was equal to 2, we'll return both of them. Okay, so based on the number of k, we have to return that many points. One thing to notice here is square root of x will always be lesser than square root of y if x is less than y, right? 8 is less than 10, so square root of 8 would be less than square root of 10. So why to check for square root? Why not directly check for the numbers? We'll use that in our calculations for simpler math. Secondly, now in order to solve this, we need few things. We need a list to store the elements with the closest distances, okay, because in the array, given array points, we can have a lot of points. Then we need to keep only k elements, and then we have to return it in the form of array like this one. So what we are going to use is a max heap, okay, max heap, or you can call it as priority queue. What happens in the max heap is the maximum number. So max heap saves the elements like a binary tree, and the maximum number or the biggest number always stays on the top. Let's understand max heap a little, okay. So a max heap looks something like this, okay. The head will always have number bigger than its children. They can be in any order, but the head will always have a number bigger than its children. Similarly, 50 is bigger than 30 and 15, 30 is bigger than 19 and 20, 15 is bigger than 10 and 5, and 19 is bigger than 2. But if you see 20 is bigger than 15 and it is under 30 on the left side, the only principle that it follows is that the head will always have the biggest number. And once you remove the head, it reheapifies itself, and the next bigger number 30 will come up, 20 will go here, 19 will come here, 2 will come outside, like this, right? So this way we can always extract the biggest number. Similarly, we can form a min heap. A min heap is the one where we keep the smallest number at the top, okay. So this is what we are going to use to find the k closest elements, because every time we remove one number from here, the next number would be the closest one, which is 30 again here. Next time we'll have 20 here. It reheapifies itself, okay. I will make sure that I create a video on the binary heap, the max heap and min heap, and I'll share the link on top, okay. but up until now you can search the max heap, how it works, how the priority queue works, and then we can work on it. So let's jump into the solution and try and understand it. Okay, it's not that complicated, it is slightly complicated, so please pay attention. I'll try to keep everything with the comments so we can understand it. Okay, so first thing is we need a priority queue, okay, or the max heap. So we'll say create a priority queue. Now we'll base it on the distance, right? So we'll base it on the distance from the origin, right? And how do we create a priority queue? So we can actually directly say priority queue will pass integer array pq is equal to new priority queue. But with this priority queue we can pass in the information in form of lambdas, that how do we need to prioritize the element. So we'll prioritize the element based on the distance, right? So we'll pass it through lambda expressions. I'll explain lambda expressions as well in another video. So, or you can search it on Google. We can use a lambda expression to define the comparator for the max heap. Okay, so what the lambda operation expression is going to do is it's only going to provide the comparison between the 2 points based on their squared numbers. Okay, so we'll say the lambda expression compares points based on their squared distance. Okay, so how does lambda function work is, let's understand it. So here we can pass it, how do we want to prioritize the queue. So we'll use the lambdas, we pass a, b, they are nothing just as two variables, and this is the format of a lambda expression, and then we provide our logic what to do. So we are going to use the integer.compare method, integer.compare. Okay, now what integer.compare method does it returns 0 if a is equal to b, it returns -1 if a is greater than b, it returns 1 if a is greater than b, it returns -1 if a is less than b. So now we are creating a priority queue, and we are passing a logic that for any two numbers, so you can consider any two numbers a and b, you compare them. Okay, and then how do you compare? We'll provide the logic. So we'll say b0, okay, into b0 plus b1 into, we'll do b1. So instead of a, b, we are passing the b first, so it will form it in the manner of descending order, so like the max heap. So we'll always have the bigger number in front of it. Okay, so we are saying b0, so this is, we are using this formula. Okay, we are directly trying to find the squared number. If you see, for the Pythagoras theorem, we need this side square plus this side square and then root of it, and we don't need to find the root actually. If this side square plus, as we discussed earlier, right, if 8 is lesser than 10, square root of 8 will be lesser than square root of 10. So we are trying to find the squares. So b0 into b0 plus b1 into b1, that is the left hand side, and we'll compare it with a0 into a0 plus a1 into a1. That's it. This is all in lambda expressions. Okay, I will close it and done. Now we'll iterate through. So right now we have only created the priority queue. it does not have any elements. We have just created a max heap, like we discussed here, that we have a max heap. If you add any number to it, the maximum number will be stored on the top and the lower number will go at the bottom. Okay, so now let's check what else is left. Okay, we have created this. What do we want to do next? Yeah, now we'll iterate through this array points. Okay, and one by one we'll add these points to this priority queue. So they'll be added in the format that the biggest one will be in the front, right? So we can say iterate through each point, iterate through each point in the given array. Okay, so for int point from points, since it's double array, it's array of arrays. Okay, and we'll add them one by one to our queue. So add the point to the priority queue or the max heap queue. So we'll say pq dot offer. That is the format that we use to add any element to the priority queue. Now, since we have to return only k elements, if one by one we add all the elements, it will have all the elements in the descending orders from the closest path, right? So what we want is, we want to keep only k elements. So anytime we have in this list elements more than the size of k, we'll remove the elements from the front, so that the highest distance element will be removed first and the closest distance element will remain in the list. So we'll say if the size of the queue, or I'll say priority queue exceeds k, remove the furthest point, or we can call it element, right? So we'll say if pq dot size is greater than k, we'll remove one element. So we'll say pq dot pole. Now once this loop is done, at the end of this, now we have total k points saved in this queue, and that is our answer. But that is not what we can return. We have to return it in form of 2D array, right? So we will say, is the for loop over here? Yes, the for loop is over. Okay, so we'll just simply create a result array. Okay, so we'll say int 2D array result is equal to new int. K is the total number of elements, 2, because it has only 2 points, x and y, right? Now we'll populate the result array. Okay, so we can say while k is greater than 0, one by one we'll copy the elements from the list to our array. Result k minus minus, or actually we should do minus minus k. Minus minus k is equal to pq dot pole. Okay, so we'll remove the elements from the priority queue, and one by one we'll add them to our result. And in the end we can simply say return result. Okay, let's try to run it. Oops, somewhere something is incorrect. This is line number 7. We're doing A, we opened the bracket from here, we opened it again. For B we closed, we extended integer dot compare, we opened the bracket, b into b plus b1 into b1. Okay, we don't need a closing bracket here. Okay, let's run. Oh, sorry, this should be part of the comments. Run. Okay, let's see. Okay, beats 50.74% of the users. Okay, the solution is not very efficient, but this is the most efficient solution I could think of. There are certain other things we could do, but I'm not sure. Please let me know in the comment section, okay, if you have a solution better than this one. But yes, there is one thing that we can do. If you understand the how we are dealing with overall our lambda expressions and everything, we can directly use the lambda expressions. We can directly sort an array, okay, and we can then just return the array. So rather than keeping a max heap and everything, the overall time complexity would still be, it would be O of n log k, okay, but we can improvise it, okay. Let me show you. So we'll restore to default, okay. Simply in two lines we could write this solution as arrays dot sort, okay, and now we pass our array points that is to be sorted. Now we pass a lambda expression, okay. How do we pass the lambda expression? As we just saw, a b. So in arrays dot sort there are two sorting method, where you first is where you pass the array that can be sorted. Another one is you pass the array and you pass the sorting algorithm. So we are using the other one, we're passing the sorting algorithm, okay. We can use the same algorithm that we discussed. So we'll say a0 into a0 plus a1 into a1, okay. So this is our left side, minus, we'll say b0 into b0 minus b. So you can consider that they are in bracket. We remove the bracket, or we can remove the bracket. Wait, where am I? Okay, b1 into b1, okay, and then this, okay. Or this minus you can actually remove and mark it as plus, and you can keep these two in bracket from here till here. Oops, yeah, right. It is I'm writing this expression, actually it is same as writing a into a in same as writing a into a plus a into a, and then doing a minus and whole of b into b plus b into b, okay. You can understand this is a1 and then a2, okay, b1 and b2. But now we can do that, we remove these brackets, so minus plus becomes minus here, right? So that's why we remove the bracket for simplicity. Now I'm saying arrays dot sort, I'm passing this array and sorting them on the basis of a square minus a square plus so first point squares minus second point squares, right? And then I'll simply say return, now that our array is sorted, right, arrays dot copy by range. This is one functionality we can use. We'll pass the points starting from 0 till k. This actually internally uses the same algorithm. I didn't showcase this solution in the first attempt, is because the first one is easier to understand. I have missed something. Let me check. The opening bracket, ab k a square into a square plus a1 into a1 minus b0 into b0 minus b1 into b1. There's one extra bracket. Okay, let's see. Cannot find symbol. Method copy by range. Something is wrong. Return arrays dot oh, it's not copy by range, it should be copy of range. Run. Okay, let's check. Okay, so the video has gone a little longer than usual, but this is just to inform that we could have used this approach directly. Oh, it does beat 84% of our solutions. Let's check if our first one was really that bad. Can we resubmit it? Not sure, but our second one is much better. But though the overall algorithms are same, this one is better because we are not using the max heap, we are not working with the heapify functionalities, so this solution is much better. You can go with this solution, but I would appreciate that everyone goes with the first solution, understands it, and then opt for the second solution. Okay, this is very simple. We are using the sorting method, we are doing an array sort, we are passing the functionality on how to sort by passing a lambda expression, and then we are simply returning it. Okay, so that's all for everyone. That's all from today's video. Thank you everyone, and please like, share and subscribe.